Hi everyone, and welcome to our video on graphing two non-shifted cosine functions. So cosine, let's scroll back up. Cosine always looks something like this, and it follows the same process as the sine functions that we did in a previous video. Okay, so we know it looks something like this, and then we'll do our process that's still up above right there. Okay, so for number 3, graphing this y equals 9 cosine of 10x, we would say, well, that's our a value. It's positive. So again, I usually don't make any type of note of that. However, they will want the amplitude, which is 9. And then we see, oh, here's our b value. B is 10. And then the period is always 2 pi divided by b. And we can instantly just put in 2 pi divided by 10 if we want. And then look to reduce. This one simplifies 2 and 10 reduce. So our period is pi over 5. Okay, so there's the two things that they want besides the graph. Let's get our graph now. Okay, so with our graph, I'm going to draw the generic cosine function first. So our a was positive, so I should start up here. And then I'm going to try my best to draw the cosine curve. There we are, something like that. That's pretty good. Okay, and try your best to draw. So as a little side note, for instance, like if you drew something like this, I would say, I mean, you could probably do a little better, right? You could change that up, erase it, try again. Okay, so because it's nice and symmetrical. Okay, so be careful. Okay, so either way, make sure to label the way that we labeled like those sine curves up above. All right, so our amplitude is 9, so that means we can mark the 9 and negative 9. And then now we'll use our period. The period goes from 0 to pi fifths. So I just mark the x-axis like that. And then this is where I use my half times 3. So this part right up there, right above. So we're going to half this value, which is really timesing the denominator by 2. That would be pi tenths. So there's the halfway points of our cosine curve. And then we're going to half it again, which means to multiply the denominator by 2 again. And that gives us our next midway point. So from 0 to pi tenths, pi over 20 is the midway point. That's where the cosine curve would cross the x-axis. And then we're going to times that value by 3, which is really just times the numerator by 3, which would be 3 pi over 20. And there we are. And let's box it. That looks good. And we could double check. If I plug in a point, so for instance, right here, I've got the point pi tenths and negative 9. So if I plug x equals pi tenths into my equation, which is 10 times pi tenths, notice the tens would cancel, and I would have 9 cosine of pi. Well, cosine of pi is negative 1. So I'm just squeezing it in there. 9 times negative 1 matches that y coordinate. Okay, so it shows that it's correct, or at least that point is. And if you have lots of time, it might be worth checking all of them, but they will all work here. So I would always at least check one. Okay, so let's see this number 4. All right, so breaking it down, we've got a is negative 3/11. Okay, so that's negative, so I like to make a note. This means we will reflect. Okay, so the negative means reflect the curve, but they still want the amplitude. The amplitude is positive 3/11. So the amplitude is always a positive value. However, again, this is more important that because it has the sign. We do want to know the sign. Again, the amplitude's nice, they like it, but the negative tells you how to actually do the full sketch. Okay, and then our b value is the coefficient that's attached to x, so 2 pi over 3 is b. And then now we'll set up, our period is always 2 pi divided by whatever b is. In this problem, we have 2 pi divided by 3. And then here we have a fraction and a fraction. What I would do is multiply instantly by that denominator down there so that I can cancel it out. But up top, continue with desimplifying. So that means we've got 2 times 3 is 6. Attach the pi. Left over in the denominator is 2 pi. And so then we see, oh, 6 divided by 2 is 3. And then the pi's cancel. So our period is just 3. Okay, so it doesn't have to have pi in it every time. It could be whole numbers. It could be fractions. All right, so let's see the rest of this. Let's get the full sketch. Okay, so kind of like the one above, because it was reflected, I'm going to just draw a dotted cosine curve that would not have been reflected the best I can. Okay, that's pretty good, I think. And then now I'm going to mirror image it across the x-axis. Okay, so I'm putting my points down first to try to help, so you can mix it up as long as you're trying your best to get a good sketch. And then now we've got it. Okay, so that bolded one is the graph that we wanted. That shows the reflection. And then now we just look right back at the amplitude and say, well, there's where 3/11ths would be, and then here's where negative 3/11ths would be on the x-axis. And then they say, oh, the period's 3, so from 0 to 3 is where one full period of our graph would be plotted. And then afterwards, it would just copy and paste if we needed more. So remember, let me scroll, because that freaked out. Okay, maybe I won't scroll yet. Okay, so let's, is it freaking out? Okay, let me get that one more. There we go. Okay, so I'm not going to scroll right now. Hopefully it fixes itself. Okay, but before I scroll, let's get these x coordinates. So still the half times 3 technique. Okay, and if we need to, I mean, again, we could put a little 1 down there, because halving is to times the denominator by 2. So that means this is 3 over 2, that x coordinate midway through. And then if I multiply the denominator by 2 again, I would get the next x coordinate. That's important to me. And then now if I multiply that numerator by 3, I get my last important x coordinate, which would have been 9 over 4. Okay, so let's box that up. That is our final answer. We could again check a point. So I'm just going to label it. If you do want to, I'm going to save a little time and not do the full check. But if we plugged in 3 over 2, we should get 3 over 11 as a y coordinate. Okay, so if we plug that back in, it will work. It will take a little time, but it will. Okay, but let me now scroll. Yes, it did fix itself. Okay, so these are just one period. Remember, if you do need more, then it is copy and paste. Okay, so it's like how we did here. And what you can do on it is, I would say, just use the period value. Okay, so my sine curve ended here. I'm going to add to it, because if my period's a length of 2 pi in this problem, I would know where this, so a little messy, I would know where that x coordinate is. I just need to add another 2 pi. So that would be 4 pi. Okay, so, and then we could figure out these ones with just arithmetic as well. Okay, so just in case if they do want more points, it is just a little bit of arithmetic. However, they usually just want one period anyway. Okay, so for instance, if we wanted this cosine curve, I will sketch a small one. If we needed more points, there we go. So that's where one period ended, 3. The next period would end at 6. Okay, so 3, so you just added the period to itself. Okay, and then if we needed the next one, 9. Okay, so we can graph more, and then we could fill in those other ones too as we go. Even if we wanted something over here to the left, there's our cosine curve. Well, from 0 to 3 is a period, so going in reverse would mean we've got negative 3. Okay, so and then let me mark 0. Okay, so all of those x coordinates are just where one period ends and where it would start to repeat itself. Okay, so that's in case we need more, and again, it keeps going forever in both directions. Okay, so that's it though for this problem, for these two problems. Next video, we've got shifted curves. So we've got addition and subtraction involved. So notice these didn't have any addition or subtraction. They had negative signs, but those aren't subtraction. Okay, so notice these, if it's plus or minus, then we've got a little longer problem to deal with. But it's very much like these first four still. So if you can do these, you can do the shifted. Okay, so that's it. Thanks for watching. See you again next time.